Welcome back once again. Hope that was interesting. All right, a lot of, not new things, but interesting things are coming out with IPv6, okay? It's been around for 20 years. Nobody's used it. Still, we're not nowhere near everybody using IPv6 addressing because they're just not comfortable with it. And then when it comes to subnetting now they want you to subnet an IPv6, all right? We do have a section that's specific in the network prefix side of it. We really don't pay much attention to the interface ID. One subnet can equal 15 quintillion addresses. So we're good with that, okay? But we have a section that allows us for 65,536 subnets. So again, that's a lot of subnets. So it all depends on what you want to do. Now, I say the way Cisco, because as their disclaimer states, this is the opinion of the author, not Cisco. So now you know, this is the opinion, if you didn't know, this is the opinion of the author. So the way that the subnetting is done in the Cisco press books 200-301, they're really just doing, let's say, they take the public range, let's call it 2001, just to make it simple, all right, because it's between 2000 to 3FFFF, all right, so 2001, all right, that is a global address, a global unique address, which is by the IANA. All right, that means you use a public address, you can go out to the internet. All right, so they'll use that particular one, and then whatever your ISP is, let's say I like to use 4800, 3200, and then you can use, or what they use in the book is DB8, and then you can do the company itself, which I'll put face or I'll put bad or whatever the case. Those first three sections is what they focus on, and then the last section, which is subnetting, they really just want you to do 100. 100, 200, 3000, 4000, 5000. That's not subnetting. Then you're using the default prefix of 64. It is subnetting in a way where you're making it just simple on yourself, easy math. All right, and then because what we're trying to do is build that hierarchy that was never built before with IPv4. So they use a default prefix of 64, and then use change in the section, the leftmost number of the last section, which is 1, and then all zeros, 1, 2, 3, 4, all the way down to F, and you can mix and match numbers as you go along. It all depends on what you want to do, but each one of those will be a different company that you're using. So that's there. You'll see it in the presentation, but then I'm going to show you side-by-side comparisons, all right, of what they're doing just by doing 1, 2, 3, 4, 5, making it simple for yourself. And then, well, then it's the same thing as saying 192.168, 1.0, 2.0, 3.0, 4.0, and using a CIDR 24. Same thing. We start subnetting when we go into that particular octet or that section, and we start splicing it up into its bits. And that's what I'll show you on the left-hand side of the spreadsheet. Now, in this particular spreadsheet, I believe there is a little error in there, but in the next lecture, I look at it because I fixed that, all right? So you may say, hey, last messed up here in the incrementation. That's fine, all right? And you're right. But in the next lecture, since we have to talk about addressing again, because we get into, addressing, all right? Or in the subnetting section, somewhere in there, we'll go ahead and I'll put the spreadsheet up again. I believe it's in the subnetting lecture where I fixed that. Okay, so again, we're going to get into subnetting, all right, and just follow really the positions, because that's something that I came up with, positions. Pay attention to what I'm saying, how I break up each, that last section, that's 1000, I break each of those hex digits into their 4-bit values. The beginning line, because it's a /50, right, the prefix length. Where it's beginning and how many subnets we need, where it stops, and we normally count like we normally do for subnets. So go from there, okay? So we are going to get into subnetting, all right? The easy way, the way the book teaches you, all right? And then the way that's really subnetting, if you want to do, go ahead and do subnet, my way. See you inside. Welcome back, everybody. All right, we're going to get into, apparently this chapter in volume 1, 23, because yes, I do have the book open, all right? Gets into IPv6 addressing and subnetting. Now, we already spoke on IPv6 addressing, in the introduction. You know, and I got tired of looking at the book, and I started looking. I went out to the actual, as you see up here, it says iana.org, and for the assignments of IPv6 addresses. And the reason I did that, it's because there's a question in the beginning of chapter 23. You know, in these books, it's like the Cisco Press books. They ask you questions in the beginning. Do I know this? All right, and then it's in question number 5, the beginning, chapter 23. It says, for the IPv6 address, and they give you an FD00, then 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 1, 2, 3, 4, 5, you know, repeat it again. All right, which part of that of the address is considered the global ID of the unique local address? The global ID of the unique local address. Okay, now based on the answers, that's why I keep telling you guys, when you're doing this test, well, I said it in my boot camps. I don't know if I said it here. Look at the answers when you're taking your test, and then look at the damn question, okay? Because the answers are none. These addresses have no global ID. One starts with 2 zeros. That will be retarded. One starts with a D. No such thing. Again, 2 double zeros. And then the answer is FD00. So they're saying that FD is a global ID of the unicast local address. Now I'm here in the IANA, and I want to zoom in here so you can see this very clearly. Okay, so here's a whole bunch of reserves. So we have a global unicast right here, and this is the range. Right here, a global unicast address. This is the IPv6 unicast space, encompasses the entire IPv6 address range, with the exception of FF, right, which is multicast, per whatever RFC. INA unicast address assignments are currently limited to IPv6 address ranges in the 2000 / prefix length 3 INA assignment for this block, blah, 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 blah. All right, so I kept going. I kept going down because they said that the answer was FD00. Now, see, this says this is a global unicast, and they're asking for the global ID of a unique local address. Okay. So I go down, so I'm looking, okay, look, unique local. And it's FC00. Okay. Cider 7. Let me see if I see an FD anywhere, you know, FF. Any footnotes in here that I'm looking for? No. This is it. This is the IANA. I don't see an FD anywhere in here. Okay, so that's getting me confused. So when you're doing this test, please go to the horse's mouth and find out what the hell's going on. Okay, because it's always, the unique local address has always been FC, as you see right here. And the global, which these are private, these map over to private IP for addressing. You know, it's they make the comparison. It's like private IP for addressing. Okay. And the global is 2000:3, meaning that you can use the first 3 bits, right, to be your locally unique address. The first 3 bits will be your local address. Remember, this is a hexadecimal number here, okay? So that means that number 2 is 4 bits. You can use the first 3 bits of this number right here. So that would be considered, well, right now, 1 and 2 are on. That makes it 3. All right. I mean, well, I'm sorry. It's A421. Well, let's not even do it in our heads here. Let's take a look at what they mean with that, because that's what that prefix length means, right? So we have a 2000. All right, cool. Because I want to get this straight. I want to make sure everybody understands what's going on here. Okay, so that means 1, 2, 3, 4. We're talking about the first 3 bits of the first position, the number 2. All right, and then it's 8421. So this guy's on. That means that's why this is a 2. But if we can use the first 3 bits, okay, so we can go ahead and do, okay, so 0011. So then this would be, oh, I'm sorry, this says 7, that's wrong. It's 8421. All right, so the same thing here, 8421. So we can use this one, right? Ooh, messed up that one. We're going to use 101. That's 2 bits right there, right? This is separate. This means we can use this guy. So if we use this guy, oh, let's move along here. All right, so you use this guy. That means 2 and 4. That's 6. All right, so what is it? 6, 6. But it says 6 is reserved by the IETF. Okay. Okay. All right. All right. Because if you look at the unique locals, FE80, it's the link unicast. All right. But yet, in the books, it says, well, you can use 8, 9, and 10. No. It's FE80. That's your only. This is not coming from my brain. This is coming from the IANA, the IANA.org. Okay? Are we saying that the IANA are like behind the times? Like they don't have the latest and greatest? I don't know. All right, so, because that's what that means right there. This means that this guy is on. That's why that's a 2. But this is telling me that I can use 3 bits. Well, maybe this means 3 bits right here, 1 and 2. That would be 3. But if I have this on, that's 6. But I can't use 6 because 6 is reserved by the IETF with the same prefix. So I can't do that. Anything with 2000, maybe 2001, 2002, 2003, is that what they mean? I don't know. All right, they can do that. So for the question, I mean, the question states which part of the address, this is from their book, is considered global. Well, I forgot I'm in Notepad, sorry. I had to hit enter. Global ID, well, let's put that back. Global ID of the unique, I'm sorry, not unique. Oh, unique. I'm looking at the book as I type local address. Okay. All right. So then their answer is FD00. That's the answer. FD00. But FD00 is not even on here. Because FD would mean, okay, because if, again, globally unique is 2. And the starts with an F is reserved by the IETF. That's reserved by the IETF. Okay. This is unique local. Oh, okay. So I don't, what is this? Okay. Well, let's look at that. Let's look at the global addresses again. Where are they? Where's the reserved? Reserved. Well, 2000 is, oh, here's 2000. I'm sorry. 2000 is the global. Starts with a 2. Okay. And then we have unique local addresses. Unique local address. FC. So it's, I mean, based on the answers, I can see where everything else, that would be the only possible answer. So it's basically test taking skills. Because this is the beginning of the rest, then everything else is just really just writing the hex table out and then repeating it again throughout the whole entire 120-bit address. All right, so this would be the answer. Okay, but I don't know. Can you please break that down? Because these are, doesn't make sense, not with this prefix. No, because this is the hex number. Okay. And this is wrong right here. Okay, 8421. Now, you see, this is, if you add these 2 up, that's 3. But oh, okay. Now I can see. Oh, okay. We can do that. Okay. Or not D. No, D's not even on here. All right, well, whatever. I'm not going to bore you to death, but I urge you to please go to the IANA.org and take a look at the actual ranges from them. Go to the horse's mouth, okay, and find out what the hell is going on. Because when you turn the page, in page 6543 of volume 1, page 23, it states that the global routing prefix might not make you think of a block. Okay, hold on. Let me get to where I really... The reserved block of IP addresses, a set of addresses that only one company can use, is called a global routing prefix. Each organization that wants to connect to the internet and use IPv6 global unicast addresses should ask for a received global routing prefix. Okay, so what I gave you guys, let's go back. Let's go to the spreadsheet where we're going to do subnetting. All right, this is the IANA right here. I guess this is your global routing prefix right here. All right, and then, you know, this doesn't mean crap because this is your ISP, so that doesn't count for anything. And then this is your company, and this is the one you're using for subnet. So your global routing prefix is what counts. Even though I don't see the FD range in there, maybe I'm doing something wrong, I don't know. All right, but go to the horse's mouth, please. Go to the IANA because this reading is, yeah, insane. All right. Now, the way they teach you how to subnet in Cisco, the way they're pointing it out, they're trying to make it easier math for you. So they use, this is a prefix length. That's what this is called, a prefix length. And you saw that in the first introduction to IPv6. This is a prefix length, and these double colons represent all zeros that we've truncated to one double colon for the interface ID, because we really don't care about the interface ID. It can be any friggin' IP address you want in there. It doesn't matter. As long as you have fun with the hexadecimal table, you can go to town. It doesn't really matter. All right? You have 15 quintillion addresses you can have. This is what counts. You have 65,536 subnets that you can use. So, but Cisco wants you to have easy math. Okay? So they want you to do, all right, they want you to do this. Control-C, Control-V, 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 Control-V. See, as long as you're in the same network prefix, okay, as long as, hey, this better be the same though. That's your global, what is it, what do they call it again? That is your global ID of a unique local address. Okay, so you can actually just do 2000, right? I'm just gonna, I'm gonna go ahead and just go, see, they want you to do that, okay? And I'm going to center this for you so you can make it look nice and pretty, all right? And then I'm going to fill it in with yellow. Oh, not all the way, last one. No, it's just right here. All right, and that's what they want you to do. And then obviously you will have the double colon all the way down, and you will have the 64 all the way down. Well, hey, I thought I wouldn't do that, okay? Okay, so we'll just erase this and copy paste. Delete, Control-C, Control-V. There we go. Nice and easy. So this is how Cisco is explaining basic subnetting, okay? Well, I mean, it's true. I mean, you put a CIDR 64, and then, hell, why make your life hard, right? Because since we don't really care about the interface ID, because there's a million ways to assign an IP address, you know, all these, you know, you can do it statically, which is insane. You can do an EY64, you can do whatever. You can do whatever is a auto configuration. It doesn't really, it's DHCP version 6, bunch of different things, right? So you really don't care about the address. Your concern is here. So, okay, we'll just go 1, 2, 3, 4, 5, 6, 7, 8, you know, we'll just use, and then once we get to the F, then we go to the next section, right? And then we start incrementing by there. These will turn to zeros. We don't really care about zeros to the left, just like our paycheck. We don't care about our paycheck having zeros to the left. We care about our paycheck having zeros to the right. And that turns into 0, 1, 2, 3, 4, all the way. And then that turns to 0. And then most of everything just turns to F, right? Eventually, everything's going to turn to F. And then, you know, all 64s. Okay, that would be, you know, that's not subnetting. That's like saying this is the equivalent to saying this. 192 dot, I put 192, look at that. 192.168.1.0. Okay? And there's no double colon, obviously. So we're using a /24, /24, Okay, so then we're just going to keep it here. We'll do right there. All right, and then we'll do this number right here. All right, I'm not going to fall for that trick again. And then I'll do this here. And then I'm just going to do 2, 3, 4, 5. Yeah, that's subnetting. It's the same thing. You're using the default mask for a Class C address, and okay, you're in network 1, 2, 3, 4, 5, 6, all the way to 255. You're not subnetting anything. Okay? You're not subnetting a damn thing. Now, if you were to do 192.168.1.28, and you have a /16, oops, I don't know what I typed, // what, okay, Control C, Control V, escape that, and then, there you go, and you do a 16, okay, now you're subnetting, and now you're incrementing, not 16, I'm sorry, increments by 16, 28, okay, it increments by 16, now you're subnetting, so, you know, you got 16, you got 0, 16, 32. Oh, I put 28 there. See, I thought vice versa. 16. Okay. Now you'll be subnetting because the next number will be 32. And since we have Excel, then we can just do this. It'll be increment of 32. So we got 48, 64, 80. Now we're subnetting. Now it's subnetting. Control C, Control V. And then we just bring these down here. This is subnetting. This is not subnetting, and neither is this. Okay? You're using /64 because you don't know what the hell you're doing in IPv6, and that's why they teach it to you. This is easy math. And I'll tell you where they tell you that. Well, I don't know how I saw it. I saw it in here while I was browsing through the freaking chapter because it just gave me a headache. Okay? But you better read. You better read. All right, because you need to know. You need to know every last little thing. Okay? But they say it's easier math. Well, of course it's easier math. You're not subnetting. You're putting a 64, because think about it. An IPv6 address is 16 bits, right? 16, 16, 16, and 16. All right, so that's 64 right there. So you don't have no room to subnet. So you got to put this just to, okay, let me just keep going. No, and then the next one. I get to F, 1, 2, 3, and then you keep going and keep going until everything is F. Well, then you're not subnetting. That's not subnetting. Not by the slimmest chance is that subnetting. That's just an easy way to address, not to make you go insane. Okay? Subnetting is when you start breaking these 4 zeros apart. So that's why here, I give you a question. I should have just merged these things right here, right? Merge and center, and then merge and center. There you go. Damn, that was too many lines. Okay, Control Z. Merge and center. Okay, so these are questions that normally they will ask you over here, right? You go, oh, got to figure out the host. So here they made it simple for us. They said, okay, listen, all you got to do is just focus on networks. We don't care about this side. We don't. We don't care about it at all. Okay? So let me close this book before it gets me dizzy. It's already got me dizzy. All right, where's my bookmark? I'm going to find me a bookmark. I'll use my pencil. Okay. So now what you're doing is, now listen, I'm the only one that explains it like this. This is the way I do it. You got first position, second positions, okay, third, and fourth. Oops, fourth. Okay, I call these, let's merge in center, positions. Let's put it in caps. Positions. All right, in French. All right, positions. All right, and each position is 1, 2, 3, 4. Tab 1, 2, 3, 4. Oh, wait a minute. Let me format the thing here. Format cells. Yeah, it's not number. No, let's put general. Let's just put no custom. Here we go, custom. Now I can go ahead and 2, 4. There we go. Click OK. Cool. 1, 2, 3, 4. 1, 2, 3, 4. All right. So boom, boom. Let's center that. So this is your first position. Like the 2 is your first position. This 0 is your second position. The third 0 is your third position. And your first and your last 1, the number 1, is in the 4th position. Okay? That's how I look at it, positions, because these are not decimal numbers. These are hexadecimal numbers. This you can do in your sleep. Okay? You don't have to worry about it. All right? But this, you got to give it a little bit of thought. All right? Now, we start with the existing prefix length, which is a 50. Okay. If we add all these up to here, we have 32, all right? So we have, we have 48, I'm sorry. 16 and 16 is 32, and 16 is 48. So we have 48, so yeah. We got 16 and 16, and 16 is 48. So that means we're in the 4th, what am I doing? Yeah, we're in the 4th position, right? 49, 50. So we go 49, 50. So let's insert a line. And where is it? Insert shape. Here we go. Insert shape. Let's insert in. So our line, all right, let's make the line a different color so we can see it. Let's make the line a little, well, let's make it red so we can really see it. And let's make the line a little bit thicker so you can see it. So that's where your line is right now. It's in between the 1st and 2nd position. All right, so that's your starting point. Okay, that's your starting point. Your line is right here. Okay, that's your starting point. All right. So you say, okay, I'm in the 4th position. It says I need how many subnets? 14. Okay. Okay, so I'm sorry, I made a mistake. The line is not there. Okay? Because the line is really, okay, 30, you got 48, 49, 50, right? Where is that line really? There? Or your line is, this is 32, that's 48, 49, 50. Your line is here. The starting point is here. So was it over here? Sorry, I got crazy there for a second. All right, it's not there. It's here. Okay, that's your starting point right there. All right, and we need 14 subnets. So how many bits, as usual, like we did before, we need to borrow from this side to get 14 subnets. So we got the same thing I do normally. 2, 4, 8, 16. So I'm going to copy this line, Control C, V, and I'm going to go, okay, 2, 4, 8, 16. So now let's make this line green. Okay, so now this is our new prefix length. Because by counting by 2, as I did in IPv4, 2, 4, 8, 16 gives us 16 subnets. We have plenty of subnets that we need. All right? Okay. So what position is that? That's the second position. That's this 0 right here. This 0 right here. That's the second position. Well, what is that bit value? Well, let's find out. 8421. All right? Let's center that. Okay? And then that means your increment by 4. So you get this number. right? And you go 4, 0, 0. Zeros to the left don't count. Okay? 8, 0, 0. Well, let me see. Hold on. It's 14 subnets. Hold on. Okay? And let's just center this. All right, so 8, 0, 0. Then what comes to 3? Well, it's incremented by 4. Okay? All right, so the next one is 12. That's C, 0, 0. And then, but if we increment again, if C is 12, and we increment by 4, that's 16. That goes above 15. So the increments, that's 1. So that's 1, 0, 0, 0. Ooh, not decimals. 0, 0. And then 1, 4, 0, 0. And then 1, 8, 0, 0. Ooh. What am I typing? 1, 8, 0, 0. And then again, it's got to be 12. Well, that can't be. So it's 2. All right, 0, 0, 0. All right, and then do you see the pattern? 2, 4, 0, 0. 2, 8, 0, 0. And then if you increment again, well, that's 12, which is C. So that's 2C, 0, 0. And you increment again, 16 can't be. It has to group. Increment the number to the left of it. 3, 0, 0, 0. And then it continues. The pattern continues. Oop, not decimals. Okay? Oop, 1 too many zeros. So the whole point, this is now subnetting, where you're actually in the subnetting section that Cisco provided us to subnet. Okay? Excuse me. You have 65,000 subnets. You still have subnets in your company, I'm assuming, right? The whole point of subnets is to decrease the amount of broadcast domains. So you want a subnet, even though on the right, it's fine. You can do that because you can have, you know, VLAN 1, VLAN 2, VLAN 3, VLAN 4, VLAN 5, VLAN 6, whatever. You're not going to, you know, you can create whatever you want. All right. And the same thing goes for here, and the same thing goes for here. But this is really subnetting because you're actually breaking it to, you know, the needs and or whatever. Because not anymore the needs of the network, the needs of how many networks you have. Yeah. But, and that's why, because I don't know who has 65,000 subnets. I don't know. All right. Or 65,000 plus subnets. I don't know. That's why they tell you to do it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. There you go. And in each one of those, you have 15 quintillion addresses. Knock your socks off. Okay? It doesn't matter. But this is true subnetting. I give you a prefix length of 50. And I made a mistake at the beginning. I told you the line was over here. That was wrong. So I got confused. Because each one of these hexadecimal digits is 4 bits long. So that's why this will represent that 1, and then the other 4s, or the other zeros, will represent the other zeros, the 3 zeros. So when I said 50, well, you got 48 right here, 4950, that's your red line. That's where the line is at right now. Well, you need 14 subnets, so let's count for subnets like we normally do. 2, 4, 8, 16, boom, line. That's where the green line comes in. That's the new mask, because the new mask would be, well, I'm going to copy paste because this is giving me a problem. I don't know why. What would be the new mask? That would be a 54, right? Why? Because we got 1, 2, 3, 4. That is subnetting. And that's where the issue comes in when you're going to, let me see if I can put this in Notepad. All right. Put this in Notepad. Yeah, and please, yeah, go to the horse's mouth. All right, to find out on all these different things, control V and ranges. Yeah, we did. All right, awesome, because we're going to use them when we start assigning it in our next lecture, when we start actually routing with it. Okay, we're going to use this scheme that we just used right now so we can prove that we're right. Okay, so this is subnetting, ladies and gentlemen. Now, this is what Cisco or the author, as they're in their page at the very beginning of every Cisco press book. In the very second, you know, 2 pages you turn it into, it gives you the warning disclaimer. It states, the opinions expressed in this, opinions The opinions expressed in this book belong to the author and not necessarily those of Cisco systems. So the author, I'll say it that way, not Cisco, okay? The author wants you to do this, okay? That's not subnetting. Sorry, okay? This is subnetting. That's why they gave you 65,536 subnets for you to do, okay? That will be the case. You don't want to do that? Oh, this works just perfect. It's, I mean, yeah, no brainer there. Just like this is a no brainer in IPv4. Okay, that's a no brainer in IPv4 too. You can just do that all day, every day. But here we have a limit of 255. All right, over here, you know, our limit is I don't know, a lot. Okay, so we're not at full 65,536. So we're not going to have that issue, are we? So I guess you can do this if you wanted to. And then once you get to F, this becomes 0, or this becomes actually, well, yeah, you go F and then 0 and then 1. Until everything turns F, basically. I mean, just like here that you see that I went to C, and then if I increment by 4 again, because C is 12. Because A is 10, B is 11, C is 12. You need to know your hex table. Okay? C is 12. 12 plus 4 is 16, boys and girls. Okay? So there is no 16 in the hex table. So what do we do? Increment this guy to 1 and the rest go to 0. Right? It's the same thing we've been doing in IPv4. All right? And then you follow the pattern. You see we're increment by 4. It's always by 4, by 4, by 4, by 4. And the pattern continues. That's it. How many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could have kept going 13, 14 to get the 14 14 ones. Did I count right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I could have kept going. 2 more, but I didn't want to. All right, that's plenty enough. All right, but this is true. And I am the one that came up with positions, because that's what they are. These are not decimal numbers. These are hex numbers, okay? So the first position is this one. Second position is this one. Third position is this one. And fourth position, because hex numbers are 4 bits long. And these are the bit values for each one of these hexadecimal digits. Okay? They are all the same. Okay? It doesn't change because 8 plus 4 is 12, and 2 is 14, and 1 is 15. And that's as far as it goes. But I gave you a CIDR 50. You start from there. I needed 14 subnets. Well, then do the same thing. You draw your freaking line. You got 48 bits on, 49, 50, 2 in. All right, so I need 14 subnets. 2, 4, 8, 16. Draw your line. There's your new prefix, 54. Because 4 bits, you had to borrow 4 bits. So what's your increment? 4. That's where that lines up to. So I increment by 4 in the second position. Okay? And just keep going from there. Not that difficult at all. This, yes, elementary, no brains needed. No, none required. Okay? But this one takes just a little bit of thought, so you can understand, because even I got, caught in the trap. Oh, decimals. And no, these are hexadecimal, all right? And there are positions. Okay? Now I'm going to put this in red, just so you know that red line represents this, and this guy in green, so you know that this green guy represents that prefix. To even make it easier for you guys, okay? So it's something that you need to understand. So there's 2 ways of doing it, okay? There's 2 ways. And in your book for subnetting, they do it this way, all right? But one thing is go to the IANA.org, okay? IPv6-address-space, IPv6-address-space.xhtml, whatever. All right, do a search on Google, okay? And then they'll tell you. who's who, right? You can see the F80 reserved by the IETF. FC, oh, well, that's a unique local address. Okay. FE009, oh, that's reserved. FE80, link scoped unicast. Oh, it's a link local address. Okay. Okay. And then we got FECO reserved. We got FF multicast. Okay. And you can see here, look, reserved for loopback. This guy right here. And you want to drill down on that if you want. And they got a bunch of other ones in here. And oh, look, I like this one. 2001, all zeros with a 23. That's reserved for IETF protocol assignments. And Torito. Oh, it's a Torito as well. Okay. 2001 with 02 at the end. That's for benchmarking, whatever the hell that is. Okay. And then you just keep going down the road. All right, but again, they don't get that deep. They can't get that deep. They just can't. But yeah, that was when I was going through the chat there. I was like, well, wait a minute. How am I going to show these guys and gals how to do this stuff? Because they're just going insane. They're just going insane. They're saying to do a 2001 DBA because that's the address that you actually. It's reserved actually. Sorry, wrong keyboard. Really? I can't. Okay. This is. Let me get this. Control C. Okay, and then Control V. There we go. Outstanding. This is what they say. Okay, 2001, and they're using DB8, DB6, DB8. Okay, and then 1111, and then they want you to use colon. Oh, that's a semicolon. Sorry, colon. Let's take the highlighting out. That's already selected in there, so let's take that out. No color. Okay. Why does it have this? Not colon, dude. Colon. There we go. And then you have a 48. And this is the first company, and the second company will be 2222, and then the third company will be 3333, and then the fourth company, I guess, would be 4444. Okay? So, the hell with the subnetting section. We're just going to do it. Okay, let me see here. The term global routing prefix might not make you think of a block of IPv6 addresses. The term actually refers to the idea the internet routers can have one route that refers to all addresses inside an address block. Okay. So that's what they want you to do. Okay, that's it right there. And that this guy is like I explained in Notepad earlier, when they came to this question, which part of the address is considered a global ID unique local address? And they give you the address that they give you is like FD00. Is it 00? Is it? Yeah, sure is. FD00, and then they go 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, don't know how to count. 5, 6, 7, 8, 9, 10, A, B, C, A and C, no, not Nancy, A, B, C, D, E, F, that's what, 1, 2, 3, 4, D, E, F, 1, right? It's got to be 4. 1, 2, 3, 4, 5, 6, 2 more sections. Then we have 2, 2, 3, 4, 5, and then 6, 7, 8, 9, 8, right? We got 1, 2, 3, 4, 5, 6, 7. Oh no, we need one more. 2. Oh no, there we go. And then we have A, B, C, D. Again, right? Is that 8 sections? 1, 2, 3, 4, 5, 6, 7, 8. There we go. Ah, it's the ticket. Okay. And that's all they give you. They give you that address. And then out of this address, they're asking you for the global ID of a unique local address. So even though this is these first 4 sections is the network prefix, okay, this is the interface ID, which means the host part of the address. This FD00 is the global ID of the unique local identifier. Now, to their defense, or to the author's defense, a global unicast is the first hex digits are 2 or 3. Now remember, it's the opinions based on the author. 2 or 3 originally, all not otherwise reserved today. Let me see. So, what he said? FD? Well, first of all, there is no FD up here. I don't see it. And then 2000 is the global unicast. Which, in every other card PDF that I found that I've given my students and the books previous to this one, it's always been, 2000, 2001 have been global addresses, and the FC has always been unique local. FD at one point was a unique local, and it was deprecated. All right. If not, Google it, YouTube it, go to your previous books and find out. Just don't take everybody's word for it, will you? So we're going to use these addresses in our next lecture, so I can show you that these addresses will work. Okay. But again, they're talking about, all right, everybody's going to use, like I says down here, everybody's going to use this. We don't care what's on here because these are all zeros. As long as this number, wait a minute, this is the IANA, this is my ISP, this is the company. Oh, okay, since this is a company, this is one company, another company, another company, and another company. But what about internally in our network? Everybody's going to be in the 000 network? Oh, well, I get it. It's for just the routers to know. Okay, so if the routers know, oh, we're on the same, 1111, we're good. Our company has one subnet, 0, okay? And we have 15 quintillion addresses in the 0 network. But since the IPv6 address is more streamlined, it's better. Again, ladies and gentlemen, this is what they consider subnetting, which is not. Because might as well, now you're doing this. This is subnetting. This is subnetting. Okay? That is what subnetting is. I can understand you're saying, hey, we're in the 2001 3200 CAD, the next one is in DAD, then the next one is in EADD, then the next one is in FADD. I mean, and you can keep going on and on and on. You can do it that way. I can understand that. Different companies, the way the routers, maybe internet routers, will know, okay, well, it'll encompass all IP addresses in that network. So the routing tables may be smaller or what have you. But again, if we're concerned about doing subnets. That's why they gave us a section to subnet in our IPv6, is that we need to subnet within our network. Okay? Because we want to create different VLANs that the routers may not need to know. Well, now the routers know that in the CAD company, in the 1000 network, we have all these different networks that exist, 400, 800, C00, 1000. They're all different VLANs, and they're all different departments, they're all different floors, they're all different classrooms, whatever the case may be. But alas, there's no broadcast in IPv6. I don't care. There's still neighbor discovery. They're still shouting out, hey, I'm still here. There's not maybe a multicast, all right? But I'm still going to separate the traffic. Okay? I'm still going to separate the traffic. That's your goal. Okay? So, yeah, read your book. And definitely go to this page. I'm going to put it back up there. It's in your recording, for goodness sakes. Pause the video. Look at the thing right up here. Okay? IANA.org/assignment and blah, 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 whatever. Go there, find out, see if this is the latest and greatest update of it. Go into the RFC, drill down into it. All right, ain't nobody gonna pass the CCNA 200-301 on the 24th unless you work for Cisco, okay? Unless you created the book, all right? Unless you have a good buddy in there, or other methods to pass this test, okay? But if you just picked up the CCNA 200-301 book and you start reading this stuff, this is going to look like Chinese to you, okay? So this is subnetting. Again, I have my IPv6, the book you'll ever need. You know, what is it called? The IPv6 book, the IP addressing book you'll ever need, something like that. All right, or the IP book you'll ever need. I have it. It teaches you both IPv4 and IPv6 and subnetting in both. Okay, and it teaches you this method right here, because that is subnetting. And this is not subnetting. Cool? I think I bored you enough. All right, so that's what they like to, well, that's what they want you to understand is this one right here. This is what I'm telling you, that's true subnetting. Now, what they call this is somewhat advanced subnetting. All right, but no. But again, read your books, because I don't want you to get the wrong terminology. All right, and then you're, oh my God, Laz. No. Look at your terminology. Take a look at your IPv6 addresses, and look how they explain it. They explain it that each particular chunk means something different. And I can see that they're doing it for the internet routers, for the routing tables to be smaller. Okay, but they gave you a section to subnet internally in your company. And it's either a global unicast address or a unique local IPv6 address. Unique local being privately, all right, which starts with the FC. A global that starts with the 2000, 2001. FD, I don't know where at one point they used it, but according to the RC, or according to the IANA, there is no FD. I don't see it. I don't see it. Prove me wrong. Change my mind, right? To quote a certain individual, okay? Or show me how I'm different. Just don't tell me, show me. Anyway, read your book, that part on subnetting carefully. Go to the internet, but I'm telling you, you can do it this way. It's easy. It's the same thing as doing this. Okay. And then, or you can do it my way, actually subnetting and understanding the different positions and how it increments based on the bit value of that particular position. And that's how you increment by. Cool. This right here is true subnetting. I'll see you guys in the next one.